I'm David Walters, and this is Innovatio. Welcome back, everyone, and welcome to today's show on Innovatio. Thank you, first of all, for the early subscribers and listeners. It's been great receiving your feedback. Please continue to like and share and follow across the social media platforms. On today's show, I have James Dunthorne, founder of Fleet UAS. James, welcome to Innovatio.
Hi there, David. How are you doing?
Yeah, good. Thank you. Good. Thank you. Thank you for joining us this evening on the show. It's great to have you here.
Thank you for inviting me, David. It sounds like a great initiative you've got going on here, and we're very excited to see how this develops.
Thank you. It's been a passion of mine for many years, and I think I've wanted to be able to share my connections and insights that I have in the industry in a format that's accessible to everyone everywhere, and this just seemed like a natural progression for me. A nice little personal prep project, as we say. But no, it's great to have you here, James. And I'm really excited about some of the stuff that you're going to talk about today, because for me, I certainly put you in the pioneers and innovators section. We started in the industry around the same time, and I'm looking forward to what you're going to share with us today. So let's jump into that. For those that aren't familiar with you, why don't you give us a little bit of background about yourself?
Yeah, so I've kind of been in the industry, I guess, for about 10 years now. I think this summer was actually 10 years bang on. So I started off all the way back at university doing flying helicopters around the room using computers. So from a research perspective, and sort of studied collision avoidance technology, trying to prove these systems were safe, which I know is probably an area quite close to your heart, David. And then I started in industry probably about 6 years ago. Started off in agriculture. I'm originally from Norfolk, so clearly agriculture is a big thing out there. So it sort of seemed like a natural route for me to go. Quite quickly realised there's not a lot of money in it, or there wasn't at least back then. And it takes people a while to sort of mature those markets. But that led me into sort of the surveying world and the later roles that then followed.
Fantastic. I mean, that's another guest that's had a more exciting start into the unmanned world than I had. I predominantly came from an IT background, and then through model flying, etc., kind of fell into drones. But the previous guests I spoke to have, been playing with Mars rovers. Yourself flying helicopters around labs. I obviously.
Well, it's good fun, because the thing is, as a drone pilot and managing drone operations, it's always good to understand how these things work. And I think that's missing from a lot of operators. Is they can read the instruction manual, but actually to understand the algorithms that sit underneath can be quite useful when you're looking at building up a big operation and mitigating risk. Recently we've seen some incidents regarding magnetic interference, which have been causing a lot of problems. And I've actually helped design these algorithms that help to navigate these systems. And so understanding the way that those algorithms work really helps when it comes to sort of saying, okay, well, magnetic interference is a really big thing, and it should be taken seriously. So yeah, I think there is definite benefit there. And clients that I work with, understand that, even when you're just doing consultancy, whether that's safety cases or whatever that is, understanding the way these systems work and can navigate is really useful for sort of looking at safety.
Yeah, absolutely. And I think, with the technology that's on the market now, it's very much open a box, get it out, charge the batteries and fly. And I think myself and you and many others in the industry who started 10 years ago when we were building these systems ourselves. We didn't have smart intelligent batteries. We didn't have redundancy in flight controllers or IMUs. We were literally just building these things ourselves, testing them out in open fields ourselves, or it was like you in a lab. And it's really...
I remember back in the days when I was, we started off with helicopters. So I pretty much learned flying the most difficult type of aircraft you could get, which was like an unstabilized helicopter. I don't know if you remember the T-Rex 250s, 450s and 650s. Yeah. These things, I look back at it and I just think, how on earth like that got through health and safety, I haven't got a clue. But these things would like chop your fingers off, no problem. And but because of that, you had to just employ very serious like risk mitigations. You had to like do things properly and think about things before you do them. You couldn't just make mistakes. But a lot of the newer systems, luckily, we don't have all of those issues. We've not, they're stabilized systems. They pretty much fly by themselves. But it's taken us a while to get to that point, I guess.
Yeah, absolutely. And I was only saying the other day, the things, if I had the technology we have today, back when I started, I'd probably be somewhere a little bit different at the moment, maybe not, I don't know. But it would have been a far sight easier than balancing cameras on servo controlled gimbals and playing with IMU settings and stuff. But anyway, I guess, it's that experience that you've kind of learned over the years that's probably led you to some of the interesting roles that you've had with a few organizations. Why don't you tell us a little bit more about those?
Yeah, so sort of I see myself as a bit of a problem solver. Like that's really sort of ingrained deep down into me. I like reworking systems. So anything that's new and innovative is right up my alley. And so that kind of got me into, when I was studying my PhD, I was also setting up a company in the agricultural sector. So surveying crops, looking at things like black grass, yellow rust, and all of these other diseases and invasive species that you get in crop fields. So we sort of developed some algorithms and basically would process that data using sort of hue, saturation, intensity transformations to be able to look at that data and be able to pick out those problems in the fields. So that's really how I got into it. But when we'd capture these fields, what I'd notice is sometimes there would be like a little farmhouse in the middle of the field, and you'd be like, that 3D model looks really cool. There must be other applications for this. And sort of within about sort of 9 to 12 months, I kind of realized that this is going to take a long time for farmers to sort of bring this on board. It was a hard slog, and realized that where the money was really at that stage was in surveying and infrastructure. The more industrialized applications, and using those skills from photogrammetry that I learned, I then use my problem solving skills to then try and optimize that process. And I started that when I was at Remote Aerial Surveys. So Remote Aerial Surveys are part of Richard Allett Associates, and they were on the Network Rail framework. So they do a lot of work on the railways, surveying, GIS, CAD, that kind of work. Really great company doing some fantastic things. And at that point, I was there for probably about 2 years, and then ended up moving across to Plam and Craven and sort of stepped up in sort of focused more on the real survey side, so less on the GIS, more into the surveying and CAD work. And there, I basically went in there and sort of said, look, I think there's a real opportunity in the rail market here. You guys are experts in producing railway surveys, and I kind of saw my skills in photogrammetry, mixing them with what they were doing at Plam and Craven, and brought those together to really sort of try and optimize that process. And on paper, I'd sort of worked it out. I'd spoken to project managers from Network Rail, and realized that there was a huge need for this in the industry. Network Rail were crying out for a change, because at the moment, or prior to these developments, Network Rail would basically have to close down the railway line to be able to survey the track. And you generally do that during what they call a possession or a line block, and that would be at 2 a.m. in the morning. You'd get maybe 2 or 3 hours. And if there was any delays, you'd lose your slot and you'd have to wait another 4 weeks to get another slot. So these
Wow,
surveying projects,
I mean, that's really inefficient just there, isn't it? I mean, book a slot, miss it, then wait 4 weeks. I mean, that's just
exactly. And the thing is, when you're doing that, what you end up seeing is, the reason why they're doing these surveys is because they want to replace the either the switches and crossings or a bit of railway track. They want to make some modifications, or they want to start the design work to lead to those modifications. And they need to do that because they need to replace the track sort of every so often to go and keep the trains running, and keep people moving, basically. So if they end up getting delays of 6-12 months through a project, it really shifts things back, and it costs them thousands and thousands of pounds, probably tens if not hundreds of thousands of pounds in project delays because of this. So being able to solve that problem and get around those issues of access to the track was a really big thing. And so I sort of looked at the problem and said, well, they need very, very high accuracies. Train lines need to be surveyed to very high accuracies to be able to replace that track effectively. And so I looked at the problem and said, well, is this possible? Looked at the kind of basic maths of the problem and said, well, okay, if we optimize every single part of that photogrammetry process, we use the most accurate control we can, we use the best GSD, the lowest resolution or highest resolution cameras we can, we capture it in good conditions, we control all of those different variables as optimally as we can, this on paper is achievable. And so when I moved to Ploughman Craven, that was really sort of my first project, was to go in there and try and make this a reality. And so we went out there, we did trials on a piece of heritage railway. We looked at that data, we optimized the process, and there were some teething problems along the way, like any kind of innovation, that you always hit roadblocks, but we overcome those, and we got to a point where essentially we were achieving sort of 3 mil accuracy on the surveys. And we realized then that, if we can achieve 3 mil in a test environment, then 5 mil in a realistic environment is definitely achievable. And that sort of really led on to the development of that service with Ploughman Craven. And, it was received extremely well.
Yeah, absolutely. That's fantastic. And I think that's probably where I became aware of you as an individual in the industry when the work with Ploughman and Craven started to gain some traction. I think also we both have mutual friends at Aerotronics. I know you're using the Artura Zenith aircraft for some of the activities you were conducting, and I was talking to the team over there at the same time as well. So I think maybe that's where I first started to hear about the work that you were doing and the Vogel system that you launched from that. And I think what you proved then was two things. One, the data could be achieved to a level of accuracy that met an industry standard. Second of all, you proved that it could be done safely. And they're the two main drivers for any organization wanting to use an unmanned system. Can I get what I want out of it, and can I achieve it safely?
Yeah, well, this is the thing, isn't it? It's all well and good achieving high accuracies in a test environment on a one-off basis, and you see this in a lot of reports. You see this in reports from manufacturers where they quote a certain accuracy, and it's like, well, everything was perfect that day when you did that test. What really sort of, I suppose, segregates the those that can do it well are those that can do it even on a bad day or when things don't quite go right. And that's where it becomes quite difficult. So there's achieving it on a sort of a more technical level, but then there's achieving it on an operational level. And that's really important. You need to build safety factors into the methodology, into the workflows. You need to be able to build in quality assessments at the right stages. And you need to sort of overspec every survey to be able to ensure that you're, even in the spotty patches in your survey area where you might lose a bit of overlap, or you might not get quite the right sort of triangulation between images, the right base to height ratio between images, then even at those kind of stages, then you're still able to go and achieve the accuracies that you're quoted. And that's really important. Otherwise, you just end up delivering poor data to your customers, and they end up becoming not very happy about it. So that's actually probably almost as hard, if not harder, than actually achieving it in a test environment. And then, as you say, the safety aspects as well. It's difficult because you're flying these machines, which are probably, we're still in that kind of, early dot-com bubble stage, I guess, of the drone industry, where these, manufacturers are learning, day by day about, their customers' needs and about the kind of features that these systems need to have. So, actually being able to have an operation that's safe, it's not just about the aircraft. A lot of people say, oh, well, this is a safe aircraft, we'll be fine. It's aircraft, the platform that you're operating is only just one part of the actual process. You need to look at your procedures, you need to look at the people. Those three things they call them the three Ps: the platform, the people, and the procedures. You need to have well-trained staff. They need to be current. They need to be have a decent amount of experience. They need to be in a good health and sort of condition when they're flying. And then you need the right procedures in place to be able to deal with any eventualities, any emergency procedures. Even things like your pre-flight checks, as we've seen. I've seen tons of incidents, AIB reports, which are totally preventable, like with one pre-flight check. So,
Yep.
Having a very comprehensive set of checks is really important when you're operating these areas. And we battled to go and enable ourselves to be able to do what we did. I had to write safety cases to allow us to operate on the tracks, reduce distances from people. You tend to find that houses, unfortunately for those people who live there, are right next to the railway track. And when you're only flying at sort of 30 meters above ground level, it's very difficult to maintain 50 meters away from properties at the side of the track. So, you only have one choice, but to go down the operational safety case route for that. So, and that's a whole long process with that as well. So, yeah, the safety side is definitely something that is difficult. But by the end of it, we had permission to fly over live network rail infrastructure while trains were running. And to be able to fly at reduced distances from people and property, which was critical, because otherwise the operation wouldn't work.
Yeah, no, absolutely fantastic, and it's good to kind of understand that process and journey that you went through. I guess going through those test stages, because you're not only testing for the data, but it's about building that ConOps around the requirements needed to go and deploy and capture that data, especially in a live rail environment. There's so many moving objects, and not trying to throwing a pun there, but dealing with a commuter train traveling at 70 miles an hour, whilst having a team on site deploying an unmanned system. I mean, complex ConOps don't come more greater than that. So I guess, is that one of the highlights from your career then, would you say, the Plowman and Craven achievements?
Yeah, so I think you're quite right in terms of that's what probably people noticed. I noticed that a lot of people were very interested in that area, and rightly so. That applies to a range of different environments. Rail is just the beginning, but Highways Agency are very interested in high accuracy surveys because they also need them. People who do construction surveys, if you're doing sort of 1 to 50 BIM models and things like that, you need high accuracy as well. And so really the process of obtaining high accuracies for your surveys applies right the way across the industries, from civil engineering to oil rigs, to gas pipeline surveys. There's a huge range of different things that they apply to. So clearly there was a lot of interest there. But whether or not it's the highlight, I would say it's definitely one of them. Obviously then I kind of realized that I wanted to go out and do my own thing. It was I kind of built up a bit of confidence that I could come up with and innovate and do things differently, and felt that it was a good time for me to sort of move on and do my own thing. So that's really what led me into developing my own consultancy business. And since then, I've released this photogrammetry surveying course, because I realized that there's a lot of companies out there that don't really know what they're not able to achieve repeatable accuracies on a day-by-day basis. Being able to achieve them in a test scenario, as I said, is easy, but being able to do it on a repeatable level, so that your clients can, trust your data, is really important. So I basically developed this course. It's now about to be released by Copters, so partnering with
Fantastic.
Copters on that to launch the course. So it's an e-learning course as well. So you can sign up and you can sort of complete it as and when you want. You're not having to do it. You go away to a centre and give up a day's worth of work to do it. You could do it in your evenings, your lunchtime, an hour at a time. So so I thought that was given our current position with COVID-19, e-learning courses are clearly a hot topic right now. So I felt that was the right move to make. And the idea of that course is to basically take anyone, whether you're, sort of a beginner in the industry or someone who has been doing surveying for years, the skills that they need to be able to achieve, accurate, repeatable survey data from using drones, and more focus on the photogrammetry side. So hopefully we'll see how it goes. Anyway, David, try not to put the cart before the horse, but I'm hoping it will be well received.
No, fantastic. It's interesting you mentioned COVID. Actually, I wasn't intending to necessarily talk about that on the show this evening, but actually, it's a good segue into the COVID and the unmanned operations that we've seen or hoping to see come to fruition. Obviously, we saw Skyports doing their medical delivery trials, etc. How do you feel the UK has handled the response to COVID, and have you been involved in any of the responses with COVID, or do you having any upcoming work around that you can talk about?
I've got to be a little bit careful because, as I say, I don't want to put the cart before the horse quite yet on that one. But so I think drones are a very useful tool in the medical field, and my sort of angle on all of this is always to try and achieve real world results. Running trials is one thing, but actually doing it in the real world on a day-to-day basis is another thing. And that's really where the innovation comes from. And I think there's some people out there doing some fantastic work out there. And I think what the barrier is going to be is being able to do that routinely without, temporary danger areas put in place, without, or flying in restricted airspace. Clearly, those are sort of, I wouldn't say easy opportunities, but they're the opportunities in the market at the moment. Restricted airspace, danger areas, places like that. BV loss is possible. But when you're looking at routine BV loss operation in non-segregated airspace, that's really the holy grail of what BV loss is about, and that's what's really going to move the medical delivery applications forward. So we've seen, as you say, Skyports have been doing some great work. And I believe Consortic are involved. Your old company, though, David.
Another startup that I've worked for.
Yes. So they're doing some great work down in the Isle of Wight.
Yeah, Southampton to Isle of Wight. I can't remember the platform that's flying. I think it's in partnership with Southampton Uni. Don't hold me to that, but I think Southampton Uni are involved with those operations.
Yeah, so actually, I've been in discussions with them, the platform manufacturer. I forget the name now. They'll probably kill me for not plugging them, but they've got this massive drone. Basically, I think it's a twin engined aircraft.
Yeah, that's it.
Fixed wing aircraft. Yeah. So, but that's there's lots of people doing this stuff with big things out there. Big drones for bigger packages. So I'm involved in a project which is looking at very, very small drones. And the idea of this is actually that the risk involved when you're flying beyond visual line of sight with a small drone of 1 kilo, say, is actually very low. There's a lot of aircraft which are rated to 1.5 kilo bird strikes, but I don't think you're gonna win that argument with the CAA. However, there are other opportunities out there, such as flying at low altitude, which can get you around some of those regulations. And so we've got a project which we're just hanging on and waiting for at the moment to see if we will progress with that. But that project is looking at that kind of application for small packages. And when you're looking at things like test samples and medication. So, whether that's cancer drugs or things like this, in a time where, you've got COVID transmission, which is quite high, getting these things around is a big problem. And what you end up seeing is people going, lots of vulnerable people going to central places to go and pick up those items, or people going backwards and forwards from these sort of central hubs to be able to deliver those test samples. So you get all of this transmission risk, which is sort of being centralized. But if you can spread that out by having non-contactless, drone deliveries, then the idea is that you can actually reduce that sort of R rate. And so that's really important, to be able to spread, push, medical treatment closer to the user. I think at the moment we're in a situation where actually delivering stuff to people's houses is going to be very, very difficult.
Yeah, agreed.
But if you can deliver it, to their local doctor's surgery or their pharmacy, then you start spreading it out a little bit, and so that by doing that will help no end. So that's something that I'm involved with. I can't really say too much about that at the moment, but hopefully
all this suspense, James. We're definitely going to have to get you back. I think you're just deliberately holding back so we can get you on a second or even a third time at this rate. But no, it sounds really cool, and I'm really looking forward to seeing what comes next with these announcements. Yeah, it should
definitely.
Be good.
I think with medical delivery, we need to take baby steps. I always say that I think the big people in the industry at the moment, the big companies, all looking for a revolution. They're all trying to go from point A to point Z in one big step. But innovation rarely happens like that. Innovation is usually lots of baby small steps, and you break down one barrier, then you break down the next barrier. But the key thing is that every single step that's taken needs to be better than the previous. It's almost it's like the evolution of us from apes to humans. Every single step has to be better than the previous. And so it's important that we do ensure that every step does take us forwards, and that's what I've tried to do.
James, absolutely. That sounds in line with the way I've been thinking about industry and it developing, and I'm really excited to hear more when you can share, obviously, with some of those developing projects that you've got going on. So I guess that kind of leads me in nicely then with Future Flight. It's a major big event that we've got coming up in the UK, big government funded opportunities that everyone's really hoping is going to open up the innovation and enable organizations to start taking their technology and demonstrating it in real environments, let's say, and unlocking some of the capabilities that we've been held back by, not necessarily so much by technology, but by the regulator. And obviously the regulator's there to keep everyone safe, and that's all their space stakeholders. And obviously there's a bit of a walk before you run kind of approach with all of this, but I think it's good that with the Future Flight project, we're able to take the regulator on that journey with us and have them understand some of the technology that's being deployed under Future Flight. And I know there's a couple of organizations putting several bids into Future Flight. How do you think Future Flight is going to kind of put the UK back at the forefront of the unmanned industry, let's say? And are you able to share or discuss any of the opportunities or the tech that you'd like to demonstrate under Future Flight?
Yeah, so I think there is lots of initiatives within that space. You're looking at the platforms by themselves, but really what we're in a stage with is it's all about systems integration. It's all about pulling all of these different things, these different parts together to go and create a fully working system. And the CA are working really hard trying to develop the regulations to support that. I think you're a part of the Unmanned Electronic Conspicuity Working Group from the CAA as well. And there's some great work that's going on there, trying to define what those requirements are for non-cooperative collision avoidance or self-separation, whatever you like to call it. But some of those things are really key, as is UTM. UTM is another area where we need to be able to safely separate aircraft. And this is the key challenge for us at the moment. Looking at air risk, if you haven't got a pilot on board with eyes, then how do you replace that? It's actually quite difficult. You need to firstly be able to see and then avoid. And there's lots of different layers to that to be able to maintain the kind of safety that you need. So I think that's where one of the biggest developments is going to come from at the moment. I see some huge growth in that area. And certainly when the CAA do eventually mandate conspecurity, which is, in the pipeline within the next sort of just over 3 years, I think they've said is the deadline for when this is going to be mandated. When that happens, the floodgates are going to open. So just watch this space. When that happens, I will predict on your show that we are going to see an extreme acceleration in this industry. So that's what I'm waiting for. That's what I'm planning for, and that's what I'm building for.
Future flight is really, I hope, I have so much passion for this industry. I hope future flight is that unlocker that we need in the UK right now, but also it gives the companies that are participating in the UK also the ability to potentially export their IP generated under future flight outside of the UK. And there's so much innovation and good tech happening in the UK at the moment, and the ability to showcase that and take that outside of the UK, I think would be fantastic.
Oh, massively. And actually one of the, I think one of the big benefits is actually going to be one of the side effects that's come from the competition. The fact that the competition has encouraged companies to talk to each other and engage with each other and collaborate. It's not necessarily the actual projects that maybe come up with the innovation, but it's the relationships that have been formed through that process. And it's clear that, we can't work by ourselves in this industry. If we work by ourselves and be isolationist, we're not going to get anywhere. We need to be able to work together. But it's okay to be able to work together, but also compete. There will be, every company out there has competitors, but we all have the same objective. So we all want a piece of the pie. And so the key point there is that we want to be able to create a pie in the first place, because with zero pie, there's zero slices to have. So it's really important that companies collaborate with each other and work together and learn from each other to be able to make this industry, turn us into this sort of aviation 4.0. And I think a big part of that is actually, collaboration efforts, which is going to really sort of push things forward.
Yeah, no, absolutely. It's interesting you say that, because even like post the future flight bid submissions that I've been involved with, I've already had separate meetings with some partners about other grant opportunities, and also some self-funded initiatives, etc., that we're actually starting to look at. And I think, you never really know what another organisation has got in its toolbox. And it's only when you start sitting around a table and start saying, "Hey, well, I've got this piece of the puzzle, and well, we can do this, and and we've got this facility available." That's when you start to go, right, okay, I can join the dots now and actually deliver something meaningful in a cost-effective way that's going to deliver real benefits, to the industry. And I think that's what we all want to do.
Yeah, exactly. And if you look at this kind of hockey stick curve of a startup business, you always have that sort of morphing phase where you test the market, and the market gives you some responses, and it says, well, yeah, we like that, but maybe if you did it like that, that would be really good. Those learnings, being able to accelerate that sort of the bottom of that hockey stick is really useful for companies such as I've got a software company called Neuron. And we're developing stuff in sort of electronic conspecurity arena. But being able to accelerate through the bottom of that hockey stick and learn exactly what it is that companies out there want, then you can then start accelerating up the handle of the hockey stick rather than being trapped at the bottom. So yeah, it's definitely really, the more we can talk to each other as companies and be less afraid of IP and things like that, I think the better. We do have to protect ourselves as companies, but at the same time, keeping your cards close to your chest is only going to sort of make you more isolationist. So I think it's important to get that balance right.
I like the hockey stick analogy. I've not heard that one before. I'll have to definitely remember that one and keep it in my back pocket. Obviously, I will credit James Dunthorne for that. But no, it's been.
I won't charge you, David. It's all right.
Thank you. But no, look, it's been really good to talk to you. Now, how can people find out a bit more about Fleet UAS, the operational safety case service that you write? I know you're kind of heavily involved in a lot of the innovation stuff going on in the UK, using your services through Fleet UAS and obviously your survey course. What's the best way to find James Dunthorne?
Yeah, so if you go to fleetuas.com, so it's UAS as in Uniform Alpha Sierra. If you go there, you'll be able to find a training course. So I've actually got a link on that website under training to the survey course through Copters, and then all my contact details on there. Description of the consultancy that I do, the services that I provide. It's all on there really, and so if anyone wants to get in touch, even if it's just for a bit of free advice, I'm happy to talk to people and help people along the way. As soon as you get above about an hour's worth of my advice, then at the end of the day, I've still got to pay for this. So but I'm always happy to talk to people. I always like to help people who are doing interesting work. Because I'm really motivated by things that are interesting. So the more interesting it is, the more I want to be involved, and so even if that's just on a giving you some free advice capacity, then I'm happy to do that. That's just what I'm about. So and hopefully if people like what I do, then there might be something in it for me. But if not, that's not the end of the world. So I enjoy what I do. My customers seem to be happy with what I'm doing. So I think in general, it's really just about helping each other to sort of realize that what we all want to achieve, which is an industry that is growing and is booming and is solving real world issues. Whether that's delivering medication to nursing homes, or whether that's flying big packets of PPE across the channel. Or whether it's surveying railway tracks. There's so many different things that drones are good for. The bigger companies are now kind of realizing this and just need to understand those kind of governance aspects, the kind of survey accuracy aspects, and those kind of components which will help them to really establish that structure. So yeah, if you want to get hold of me, visit the website, that's fleetuas.com, and be happy to have a chat with you.
Fantastic, James. I'll ensure the links, etc., are included in the email and the video description as well. So just in case anyone is unsure, click the link and you'll be able to find James. James, again, thank you for joining us this evening, and thank you to all of our listeners and subscribers. Please keep sharing and liking the content and leaving the reviews. And I look forward to seeing you on the next show. From me, thank you very much, and see you on the next one.